Hello YouTube. We're back to profit and loss, and it's been a while since I've made one of these videos, mainly because I kept buying things and they kept getting lost in the post or having the orders cancelled. I bought an Alienware and they took a while to dispatch it and that never showed up. Yeah, it's just not been going well in terms of buying. And so it's taken me a while to find something that I thought was worth buying, but here it is. This is an MSI gaming laptop. It is a Raider GE78HX. And I paid, I think, £384.50 including postage. I think it's missing its RAM and SSD, but it did come with a charger, so that's good. Now, this is a very high-end laptop. I think it has a i9 13th gen, and the title said it had an RTX 4090. It wasn't until after I bought it that I realized the description says it's got a 4080. So what GPU this has, I don't really know. Looks to be in good condition. Now the story behind this one's a bit funny. So I bought this at auction, and I had my eye on it for a little while, and I missed the first auction. But a week later, it got relisted. I don't know if that's because of the discrepancy between the title and the description with the graphics card, or what's going on with that. But what I do know is I think this has been to another repair shop and they've attempted repairs on it. I've got no idea what we're going to find inside. So let's get on with it. Let's start by just plugging it in and seeing if it's got any LEDs or power lights, or if it does anything at all. The description was pretty lackluster on this one, so I have really got no idea what to expect. Can't seem to see any anything lighting up. The machine itself's in really nice condition. But yeah, no LEDs, nothing to indicate charging, and no response to the power button, so I guess let's take the bottom case off and see what we can see. Okay, right, let's did we get RAM? I can't remember. Let's remove the shield if we can. Why is that so sticky? Hey, we have RAM. No SSD. Okay, that's fine. That's not so bad. It's a 32 gig stick as well, that's good. Not seeing anything too worrying to begin with. Can't see any flux under the board or anything crazy like that. So I wonder why it doesn't work. I wonder what the other shop tried. What kind of repair attempts this thing has. I guess we can start plugging the charger in and seeing if we have any voltage. So I'm just going to look around the board, see where the high side rail is. The battery's unplugged, okay. We can start just by measuring for voltages. It's the battery shunt there, so that'll sense the amount of current going to the battery. Does it have any power? No power on the battery shunt. If we move up, there's another shunt resistor here. Oh, there's a bit of scratching on this MOSFET, which is strange. Oh well, who cares? Got no power into that shunt either. Let's go up here. Got a little regulator circuit here. Inductor, DR MOS or some kind of chip, and a couple of caps. So these caps are probably 19 volt input. And we have nothing. So I guess we're not getting power from the charger. Just next to the DC jack here, there's a couple of ferrite beads, so that's a good point for me to measure whether it has 19 volts from the charger. I doubt it's quite as simple as just a bad charger, but we can check. Okay, is my multimeter working? Or do we have no power in at the DC jack? I guess we've got no power in at the DC jack. I could run and get another charger, because this one is either might be unplugged, might be bad. I don't think it's unplugged. I think I plugged it incorrectly. But first, I'm going to see if there is any obvious shorts on 19 volts. Because if the main power rail is shorted, what might happen is the charger might have put itself into some sort of overcurrent protection, which would prevent us getting power to the machine. So let's switch my multimeter to resistance and go back to, there's that regulator again that I presume has 19 volts going in. Yeah. Okay, we have a main power rail short. This could be good. This could be an easy fix. 1 ohm to ground. It might not necessarily be an easy fix. We could still have a major short circuit somewhere, but at least the diagnosis is simple. Let's take the heatsink off and have a more in-depth look. I really hope it's something simple like a capacitor or, you know, something that we can fix quite easily, because I will make quite a lot of money on this if it is. Also, it'd be interesting to see what GPU this actually has, because it just seems like the seller didn't really know. I guess it could be either. Could be an RTX 4080, could be an RTX 4090. Is there a screw under this? There is. That's definitely not a 4090. Well, I'm pretty convinced it's not anyway. So you've only got 6 VRAMs around the GPU. So my bet is this is a 4080. But it doesn't look damaged, which is good. Again, no signs of flux that I can see. So I'm going to go around and check the major components that will make or break this repair. So we want to check to make sure we don't have a short circuit from the main power rail into either the CPU or the VRAM. So if the CPU's been hit with 19 volts, then it's probably toast. And if the VRAM's been hit with 19 volts, the VRAM and the GPU are probably dead. So they're very expensive parts to replace. Let's keep our fingers crossed and make sure and hope that they aren't the problem here. So let's get you under the microscope again. And let's start by looking around coils just below the GPU. GPU's up here. Actually, let's go to the VRAM itself and measure the caps around there. Yeah, my meter's working, so 27 ohms. That's probably about right. There'll be also 1.8 volts around here somewhere, but yeah, that looks good. That's a relief. Now, CPU phases, just above and to the right, all physically look good. Let's start checking resistances. 17, 12, 12, 12, 12, 12, and what are these three? Please be good. 12, 12, 100. Okay, CPU and GPU look good, which is a massive relief. Maybe I should measure some capacitors on the PCH. We could still have a high side onto the PCH. 28 ohms. Guys, this is looking really good. What about around the MOSFETs with the scratches? I don't know what these coils do, but neither of them is short. And yeah. Okay. Wow. Right. Let's just get these stickers off so I can see everything that's under the SSD stickers, which is not much, turns out. And we can, what should we do? We should inject some voltage. So, you know what, I'm going to go back to this shunt here and see if this is also short to ground, because this would be a great place to solder some wires so we can inject some power. Yeah, okay. So that's connected to that. And they're both short to ground. Let's find a wire we can hook up to the bench power supply, get the thermal camera out and see if anything gets hot. And these two pads are perfect. That'll be positive and that will be ground. It's a non-stop capacitor, so we can simply add some cables here. I guess I should turn my bench power supply view on, and so you can actually see how much power I'm putting into the machine and how much current it's drawing. Okay, I think I'm all set with this. I've got my bench power supply set up. I should turn on the thermal camera. The power supply is set to just 1 volt, so you start low and increase if nothing gets hot. Now we've already checked the CPU and the VRAM, so we should be okay to put a decent amount of power into here. It could be a GPU phase. We don't want to send 20 volts straight into the GPU, but we should be okay to at least put a couple volts in. So let's turn on the power supply and see how much current it draws. Only 600 milliamps at 1 volt, so not much power going through. Let's just see if anything's glowing. Bit of a reflection from the PCH. Nothing yet. Let's up the voltage. Let's try 2 volts. And the power's nearly doubled. And again, can't see anything getting hot. Okay, let's turn that off a second. Now, I'm a bit cautious that it could be one of the GPU drivers, and I don't like sending loads of power into a GPU. So, what I'm going to do is I'm going to find a GPU phase coil, which will be one of these lot, and check it to ground. So that's 0.7 ohms to ground on the GPU. Now let's go back and measure our short, which is also 0.7 ohms to ground. So now, I guess we measure between the GPU coil and our short circuit. We have 0.3 ohms, which is lower. So if that resistance then between the short circuit and the GPU coil increased, if it went to 1 ohm from 0.7, we would know it's taking a longer pathway to get there, and as a result, we would suspect that the GPU drivers are okay. But because that resistance has gone down, I think we've got a fault on the GPU driver. The resistance between the short circuit and the GPU is lower than the resistance between the GPU and ground, and the resistance of the short circuit and ground. So, yeah, we've got a bad GPU driver. But which one is it? Let's clean up the thermal compound on them. They are NCP 303152s. I don't know if we've got these in stock. Those first 3 look okay though. Yeah, no signs of heat or burning. So there's a bunch of different ways we can use to figure out which one of these drivers is bad. Oh, I missed one. There's one up there as well. Is that also on the... Is that on memory or is that on core? That's also on core. Yeah, so all of these are core. We could just start removing these chips and see which one lifts the short circuit. That's okay. We could remove the coils and see which one lifts the short circuit. Or let's try something different. Let's try measuring to ground on some of these control signals. So that 4.7 ohm resistor 20k. Next one along 17k, 16k. Okay, so that's not telling us anything. There's a difference there. So this resistor to ground is 15k. We move over to the next one along, it's 36k, 26k. These are all over the place. 27k, 0.45, 37, and 30. So the reason I'm doing this is if we spot a resistance that doesn't look like the other chips, then that could be a faulty driver. So far, inconclusive. We're just going to keep going, measuring resistances to ground on all of these passives nearby and comparing them to one another. And this isn't a surefire way of getting a result, but it works in certain cases. So that one's tied to ground, don't care about that. So they all look okay. I'm going to stop here for a second. Okay, I'm back. I've had a quick think. Now, there is another good way of checking which one of these drivers might be bad. It involves changing our ground. Now, if we remove our ground from the ground of the board and ground out the output side of this power supply, we should have a direct feed of 19 volts going in to a ground here. So whichever one of these FETs is allowing the 19 volts to run through it should light up. And there's no risk of damaging the GPU because this side is ground. So we're not actually putting voltage into the GPU itself, we're sending the voltage straight through to ground via one of these bad drivers. So let's just remove our ground cable here, relocate it to the GPU power output, and we can see if this works. There we go. So I'm just going to solder it to that coil there. Right, so you can see we've got a ground cable here, which is grounding out the GPU power output. So now we should just be able to turn the bench supply on again and here with the thermal camera and see if any of those glow. And we should be able to increase the power this time, but we'll start on 2 volts again. Okay, it's drawing 2 amps through one of these drivers. Nothing getting hot yet, but it does mean we do have a bad GPU driver because it's using the GPU output as ground and 19 volts shouldn't be getting there. So if the GPU drivers are okay right now, we wouldn't have a high current draw. And the reason these are hard to see is they've got a lot of thermal mass, so it take a lot of power to heat up. Let's go to 6 volts. And now it's drawing 6 amps. Nothing looks to be getting hot. I mean, maybe just a little bit of heat on that one there. Oh no, there it is. Or is that just a reflection? That's just a reflection. But this one seems to stay present no matter what. If we up our power, say to 12 volts, and if I turn it off, does that glow go away? Yeah, see, as I turn the bench power supply off, all of a sudden the hotspot goes away. So is that second? So the second phase in on that side? Yeah, so we're looking at that one. Just going to mark that with a bit of pen. Turn the supply off again. And we can drop some alcohol on this and just confirm what we're seeing. And it's starting to evaporate. It's very slow, it's very subtle. But I think that is our short circuit. So, let's remove it and see if the short lifts. This is going to take quite a while to heat up. These components have a high thermal mass, like I was saying, so Gotta be careful not to remove it too early. Right. Let's get our multimeter back out. And we're going to measure across the 19-volt rail again. And we have 3 ohms. Well, that's weird. Now, this bench power supply does have a low impedance on it. Yeah, let's unplug the cables from my bench supply and let's recheck. Now it's 16 ohms? It is increasing. But this is weird. This should be higher than 16 ohms. What? Why would it be doing that? We don't have more short circuits, do we? What was the video memory again? 9. If I measure between video memory and 19 volts, 26. Okay, so that's increasing. Okay, maybe we've got another short circuit here somewhere. I don't know what it could be. Let's remove our ground. And I've just soldered it back on over here. Let's plug our bench power supply back in and see if it actually draws any current, or whether this is some sort of weird phantom short circuit that doesn't actually exist. Let's put it up to 3 volts. 16 ohms. Yeah, it's drawing power. That's not good. Why? The board's still hot from where I removed that phase. Do we have another bad phase? Is the one to the left of it bad as well? If I turn the power supply off. I think we've got 2 bad drivers here. I think this one's bad as well. There's a tiny little heat signature. So I'm going to just remove that. This is crazy. For a moment, I really did think this would be easy. Maybe not so much. Okay, right. Did that lift the short? No. What's going on? What is going on? This is weird. Do we have... Are all of our GPU drivers bad? I'm going to remove the board and see if there's anything that will give us any clues on the underside. But this is weird. We have seemingly lifted a short circuit, but there's still definitely something going on. Oh, I can smell a bit of burning, maybe. Oh, no. No. I can see something. Was I wrong? Oh. Yeah, I know what's going on now. Oh, I thought this was so easy. Bad GPU driver. But we have a secondary problem. The PCB has exploded. I think a capacitor used to be here. Maybe someone's already tried removing this. But yeah, we've got a blackened layer, so I guess we're going to have to start cutting and see how deep it is. I don't like doing layer burns on camera, because I lose some depth perception. I have to do everything with one eye closed when I'm recording, so that makes my life a little bit trickier. You know, it doesn't look like it's game over yet. we have some burning. We're down at least 2 layers. But our aim is to remove all the burnt material so the layers can't short out anymore, because that's where our low resistance is coming from. It's all the material inside that's burnt up, allowing the copper layers to connect to one another where they're not meant to. Probably want a sharper blade or some better tools for this, but it's not so bad so far. So, I've got this little grindy pen, and it's got a rubber dental polishing bit which has a very light abrasive. It's essentially very light sandpaper. We're going to use this just to see if we can clean this layer burn up a little bit. I'm just going to clean up as we go. Shouldn't take much, we're getting close. Yeah, we're nearly there. Still some burnt material, but it's not too soft. Just got to keep digging until all the blackened material is gone. That way we know there's no chance of any layer shorts. We're pretty much there. There's still a bit just around here, but only a tiny bit. And we've still got a bit under this layer as well. I wonder if this is why it went on auction a second time. I wonder if a guy bought it, found the layer burn, and didn't think they could fix it, so they sent it back. Maybe that's what's going on here. Maybe that's why it went on auction a second time. But it doesn't look too bad, the layer burn. I think it's fixable. That might be okay. Now, you can see there was a trace that was running through this area, and we don't know where it went. So, I'm going to hazard a guess that that was either plus 19 or ground. Let's measure it to ground. Let's see whether it's the ground for that capacitor that was once there. No, okay. That's not so good. Was it plus 19? Well, it's not connected to either. Well, that makes me worry just a little bit. It could have been going to a via through one of these holes. We're going to have to figure out what that is at some point. Let's see if plus 19 is still short. Crazy. Still got a short. In fact, it's more short than it was before. Am I measuring the right thing? Let's go back to the 19-volt rail. Yeah, I've made it worse. I guess we have to keep digging. So this side here was positive. Let's clean that up. What about now? You short to ground? No. Okay. There we go, there was just a stray bit of copper between this and I guess the second layer, which will probably be ground. Yeah, that's ground. Or GPU core or something like that. Okay, right. Where did this trace go? Could have been a via. Alright. Okay, so that's 20 volts. So in this situation, we've just got to sort of keep exploring. We can either do it manually by measuring what looks like it's missing, or visually by looking at where any traces may have come from. Now, I am seeing couple of things. Is this trace just something that's peeled over? Yeah, that's a bit of a layer that's peeled over. Let's get rid of that. So it's not that. And what I think it could be is here. If I widen my cut just a little bit, add a bit of IPA, you can actually see a clear border around this here. So that means this is a trace, and it's probably running across there and is now disconnected. So we're going to have to reconnect those two. That's my guess. I could be wrong. I might be missing something simple here, but I think if we run a wire through there and then put a couple of phase drivers back on, we should be okay. We should be good to go. Let's see if I can expose those with the rubber thing. So I need a better knife to clean this up. I don't want to risk losing any more of that trace. So I'm going to fill this and put some UV cure around here, just so that when I run this wire it's not going to short to anything. And whilst that happens, I will go find some better razor blades so I can scrape away at that coating, expose some copper, and we have something to solder our cable to. I guess that second phase driver was not problematic, so I can keep that. I think the hotspot would have just been from the underside of the board where this layer burn was. That'll do. Let's cure that. So I'm thinking that this capacitor probably failed first, burnt through this trace, and this trace, having failed, then led to the failure of that first MOSFET driver that we removed, that we know was this short circuit. It sort of set off a chain reaction. Single capacitor. Sort of making a mess here. I keep bridging things with solder, but we could deal with that after we've got this trace restored. It's not my finest work, but it will do. Let's clean that up a little bit, and we can use some wick and hot air to get rid of all those bridges and make sure everything's where it wants to be. Okay, we can cover that all up, and I guess the next thing is to replace those missing phase drivers. Hopefully I've got one in stock. I think I'll be able to find one. A little bits of fluff and hair getting mixed into this UV cure, but oh well, no one really cares. Doesn't matter if you've got a couple bits of fluff inside your board. If it works, it works. Alright, let's cure that. That should be okay. Now, obviously, at some point, there was a capacitor there, but this laptop will run without it. There's no real, I mean, we could put one back. We could retrofit a capacitor over that spot, but I don't really think it's necessary. It'll survive. Let's actually just add a bit more UV cure around these edges that are still exposed. Okay, let's check one last time. Is our short gone? Our short's gone. Here's what I believe is the phase driver I took off second. So I think this one will be okay. I'm going to put this back on and recheck for shorts. And then we can put the other phase driver on and check for shorts. Just check the pins side on, make sure they're well filled out. Yeah, that's good enough for me. Always worth checking though, make sure when you're doing a GPU FAT that it's soldered properly. It's not perfect, that one, but presuming this is not short circuit, we can touch it up when we fit the second. Yep, still no short circuit. Okay, I'm gonna stop here for a moment and see if I can find another phase driver. See if I've got any of those in stock, and if I do, we can fit it, carry on, and see if this board works. Yeah, I found a donor. Perfect. Just going to straighten this one out. I've noticed it's a bit wonky, so there we go. That should do it. Joints look well made. And come on, last time. Let's check for a short. No short. I wonder if this is the kind of laptop that's going to turn on the moment I plug the charger in. I suppose let's unplug the CMOS battery, because that might help facilitate an auto start. I've got a thermal camera on, so if it does start up, we'll see everything get hot. CPU's getting hot. Okay, that's good. I only did for a second, but that's a good sign. Maybe it just overheated. Now, when you fix a phase problem, especially when it has a layer burn, what I'd recommend you do is check the phases with an oscilloscope to make sure the phase activity looks correct, because you don't want to run a system with multiple bad phases. It'll fail again. So I can't really show you that because my oscilloscope is just by my camera up here, so you won't be able to see what's on my display. But what I can do is quickly check that on the two phases that I replaced, make sure they're doing something. We can check voltage first. So when I switch multimeter over to voltage, and see if when I plug the charger in, we get 0.7, 0.8 volts. 0.7 volts. Awesome. Okay, so the GPU is turning on, which is definitely further than we were going before. I'm going to check with the oscilloscope, make sure those phases are okay. Yep, okay. And again, okay. Let's just make sure it matches up with the next one down. Yeah, there we go. Okay, things are looking good. Can turn that back off and get rid of our cables. I can put it back in the chassis and see if it does anything. But it looks like it's trying to turn on, so I think we might be okay here. Make sure we put the sticker back on the bottom. You can see where it blew a hole in that. So we'll just cover that up with some Kapton tape. I'm going to go back and deal with all the thermal compound and stuff like that a bit later. For now, I just want to know if it works. So let's get a couple of screws in, just drop the heatsink on and temporarily screw it down. And that's another thing, we could have a battery issue here because of the short circuit. It could have locked itself or over discharged or something like that. So who knows if the battery will work. Let's oh, there's a CMOS battery. Yeah, we can leave that flopping around for now. Let's plug it in. We're on DC voltage. Okay, we've got LED down there to indicate charging, which is a good thing. We have 12.2 volts at the battery terminal. Okay, that might be charging actually. That'll be really good if the battery's okay. Then I will just need to buy an SSD for it. So unplug that and pop the cover on. The moment of truth. Will it show anything on the screen? We have a power LED. So I guess now we just wait. Oh, I saw something. And the display flickered just a little bit. Because it's had its CMOS battery pulled. It'll take a while. Oh my god, I saw the logo. But it's turned off again. Yeah, it might need to do some stuff because it had its CMOS battery reset. Yes! There we go. She works. Right, I guess the next thing that I got to do is get an SSD in it. Make sure everything's working properly. I'll deal with the thermal compound. I'll repaste it with some PTM or something. We can test it all, make sure it's all working, and get it sold. So I'll pick up the video once I've tested everything, and we can go through the numbers. But we should make good money on this. It's a bit of a shame that it's only got the RTX 48 in it, not the 1490 that was listed in the title. But we should still make good profit on this, so I'm not too bothered. Okay, we're back. And I've been playing around with this laptop, I've been testing it, and it all seems okay. The buyer wanted to provide their own SSD, so we factored that into the price, but that does mean that we've spent absolutely nothing on this laptop. Now, let's talk about the numbers. So, we started this episode with £779.05. Bought the MSI laptop for £384.50. And we've sold it for £1,300. Well, to be fair, we can take £5 off because we did replace that driver MOSFET for the GPU. But that means on this repair, we made a profit of £910, which is absurd. So having sold the laptop for £1,300, it's safe to say we've absolutely smashed our target of turning £100 into £1,000. In fact, we've ended up with a balance of £1,689.55. So that sums up Let's Go Gambling Series 1. Now, I say Series 1, I'm not really sure if I should make another one of these video series. I might move on to something different. Let me know in the comments if you want to see a second series of Let's Go Gambling. I hope you liked this video, and I hope you enjoyed the rest of the series. So with that, thanks for watching, and goodbye.